My name is Anders Rinneman, and I am the program director of WASP. And we have a very exciting agenda put together. I will give a brief introduction to the program, some general aspects of WASP, and show you some of the developments and the changes that we are going through currently. After that, we will have a general presentation by Colaboration Korsén and Danica Krajic, who will tell us more of the details about what an industrial PhD student is all about and some experiences from that. We have the WASP Graduate School Director, Fredrik Heinz, who will tell us more about the graduate school components and also some changes that we have introduced to the graduate school over the next couple of years. To also provide you with a more detailed and hands-on experience perspective of both being and supervising industrial PhDs, we have Claes Lundström from Sectra, who is an advisor for Karin Stacke, who is also with us from Sectra in Linköping, and they will share some of their experiences with us. And then we'll have a Q&A session and also a wrap up, and our goal is to finish by 3:15. So I'm very pleased to see that there are so many of you that have registered for this webinar. And as you know, the WASP program is by far the largest individual research program in Sweden ever. And the budget has grown over the first couple of years of activities and is now up to 5.5 billion Swedish kronor for 15 years until the year 2030. Out of that 5.5 billion, 4.2 comes from the Knut and Alice Wallenberg Foundation, and the rest is matching funding from universities and industry. The vision and the mission that was set up at the very beginning of the program still holds. And it's based on the firm belief that the best way to promote Swedish society and in particular Swedish industry is by conducting basic research that has a high level of relevance to Swedish industry. So the mission here for WASP is really to build a world-leading platform for the academic research that we want to support. But in doing that, in a strong interaction with the leading companies in Sweden, and really to develop the knowledge and the competence needed for the future to create competitive advantages for Sweden as a nation, and in particular our industry. The WASP program is not in isolation. There is an environment, an ecosystem of other initiatives that are going on. I will not go into the details of this in my presentation, but I think it's important to be aware of other things that are going on around us. We have one sister program dealing with ethical, legal, societal aspects of our domain. As you know, this is something that is of high relevance and importance to society. So we have the WASP HS program. We also have a computational infrastructure, since we are dealing a lot with machine learning, and the computational resources are in need for advanced research in this domain. So we are putting in a computational infrastructure. We're spending about 300 million Swedish kronor on the build-up of an NVIDIA superpod hosted by the National Supercomputer Center based in Linköping. There are other initiatives such as the WINC, the Wallenberg Initiative on Networks and Quantum Information. We have the mathematics initiative by the Wallenbergs, and also the initiative on quantum technology, more from the hardware perspective. Most importantly, I think in this image here is the new initiative that was launched in the fall in data-driven life science, where we see that WASP will have excellent opportunities to collaborate with, and we also have dedicated funding for collaborations with the DDLS initiative. So a little bit about the whole context for WASP. Now, WASP builds on a number of different instruments, and the industrial PhD program that we will talk about today is as a part of the research program, which is one of the main instruments for us. A number of different projects, kinds of projects, primarily I would say at this point, PhD student funding has been a part of the research program. But we also have the graduate school, and Fredrik Heinz will tell you more about that, and providing highly relevant courses and other social networking activities for our PhD students in the graduate school. Recruitment is also a very important part of WASP, where we are looking at recruiting top talent to come and join us in Sweden to build competence and make the Swedish environment even more attractive and internationally competitive. We also have an initiative on research arenas that we're providing platforms for collaborations with industry in targeted areas, and I will say a few words about that towards the end of my presentation. We're also looking a lot at internationalization and collaborations with leading partners all over the world, such as Stanford, Berkeley, MIT, and NTU in Singapore are our primary partners at this point. And of course, we have a large number of events and networking events that we are organizing, and a lot of communication. You will hear more about that as well. Now, if I bring up some of the main highlights for you for WASP, I mentioned the budget, but in terms of recruitments, we have recruited 8 very senior professors in autonomous systems and software to come join us in Sweden. We have recruited 9 Wallenberg chairs in artificial intelligence. We have 20 assistant or associate professors in artificial intelligence. And of course, the graduate school now has about 300 PhD students, and almost 100 of them are industrial PhD students. And 40 companies are then in one way or another engaged in the program, primarily through supervision and participation in the industrial PhD program. We're looking at postdoc programs, industrial networks, and also mechanisms for supporting innovation and research validation. And as I mentioned, the WASP HS and the data-driven life science and the amazing infrastructure that we're putting in place. So this picture here sort of summarizes the main highlights that we are looking at this moment. Now, we have also recently just upgraded our target numbers in terms of the number of PhDs that we are going to put through the system by the year 2030. So the goal is 600 PhDs, and 150 of those should be industrial PhDs. And the ambition is also to build 18 new strong research groups, primarily through recruitments of talented people. And you may have heard of our new initiative called NESTs, and I will say a few words about that in just a few moments. One of the things that we did during 2020 was to develop a narrative, a strategy, and a goal in terms of a document that we have, and it's actually available on our homepages. It's a rather lengthy read with lots of details about the program, but it contains the visions and the ideas for where WASP is going by 2029 or 2030. So in this document, you will find a couple of main conclusions after the analysis that we've gone through. And our main conclusion is that we are doing pretty well. WASP is really contributing to many of the goals and the missions that we have put up. But we needed to have a closer look at our clusters of PhDs, how we are categorizing different PhDs, and how we are enabling the networking, the social aspects between the PhD students. One of the things that's really clear and that has high relevance to this particular initiative that we're talking about today is the industrial relevance and the collaboration. And even though we are doing well, we would like to further increase the industrial relevance, and also the research arenas. We'll have a new initiative coming up this year, and a couple of new instruments that we needed to create to promote networks of excellence, and also to put us in a position to address some of the really hard research challenges with potentially very high impact. And one of those is the WASP Nests, where we really want to put together very strong researchers, 3 to 5 PIs, who will join forces to attack a problem that really requires a multidisciplinary team of researchers. This could be a physical environment that you may want to build, or a network of excellence. And the board has so far approved that we will fund 6 of these nests. The call is open and it closes on March 1st. And as far as I know, there is a lot of activity going on in the country for people to develop the proposals to become one of those 6 nests. the research arenas, we're moving into a new domain. We call them the WARAs, the Wallenberg Research Arenas. And we are launching now the 2.0 initiative, where we are looking at going beyond the initial arena, which was focusing on public safety. You can see in the picture here, you can see a sea rescue operation where we put together autonomous vehicles, even submersibles, UAVs to rescue people at sea. And there's a lot of interesting data that has been generating through this public safety scenario. But what we're looking at now is also going beyond that and looking at new arenas that will perhaps attract even more students to showcase their research and also find research challenges inside of the research arenas. Such an initiative is in software, in the software domain, and also one in media. And we are currently discussing things like natural language processing as well. So there's a lot of activity going on in search of the research arenas. And I really encourage those of you who are listening who have any kind of industrial research interest in these arenas to contact us to be a partner and participate in the new research arena initiatives. Another initiative that we're looking at is also to build bridges between industry and the academic world. One of the challenges that we quite frequently see is that the academic research agenda is very tight, and it's sometimes hard to motivate that you're taking one step into the interest domain of a company. Even though the problems for the company are very relevant, it's hard to motivate that your PhD students or other research staff would spend a significant amount of time working on industrial problems that may not be at the research forefront. In the same way, it's hard for companies to motivate that you're spending time on very long-term initiative development and research. So what we're trying to do here is to build the bridge between those two different worlds by actually providing funding for research engineers to not necessarily conduct research, but actually do something that enables future research between a company and an academic environment. And it's our hope that funding of 3 to 6 or 12 months of a research engineer to do programming work or other kind of engineering work will help us to build these bridges. And that call is open and closes on the 28th of February. So again, I think this is an excellent opportunity if you have an idea that you want to explore a little bit further. The topic of today is PhD students and the PhD student call, and we will have 2 PhD student calls this year in WASP. One of them is, of course, the industrial PhD student call that we're talking about here, and you will hear momentarily much more about the details of this call, where we are up to 10 PhD students will be admitted to the WASP Graduate School. But there's also an academic call coming out later on in the spring, where we are looking at more academic-oriented PhD students, and could either be in the form of twinning of students or single, very targeted PhD students in one particular domain of high interest. So I think this is a very brief executive summary about what WASP is and where we are at this point and where we're heading. And this slide is a perfect transition to talking more about the industrial PhD call. So I'm handing over to Karl-Erik Rosén.
Okay, I assume you can see my slide. So my name is Karl-Erik Rosén. I'm from Lund University. And I will speak a little bit about the general issues with this industrial PhD student program. And then Danis Zakragic from KTH will also say a few words. So why an industrial PhD program? Well, the main reason is that collaboration between industry and academia is very, very important for disseminating knowledge from research to industry and to get good research questions to focus on in academia. So the purpose of WASP Industrial PhD Student Program is to contribute to needs-driven research and to foster in-depth cross-fertilization between academia and industry, both in terms of relevant research results and availability of competence. The Swedish PhD education is normally 4 years if you do it full time, but normally you don't do it full time. You do it at 80% level, and that means that it takes 5 years. University PhD students, they spend the additional year doing teaching typically, whereas industry PhD students, they spend this year working at the company doing non-research related tasks. 4 years correspond to 240 high school credits, as it's known. All PhD students, they are required to take between 60 and 120 credits of courses. That varies from university to university and from department to department. Most cases, it's 90 credits of courses, and that corresponds to 1.5 year full-time studies. And the WASP course package, so to say, in the graduate school in WASP, that consists of 27 mandatory courses. That means that a PhD student, an industrial PhD student that starts as a WASP industrial PhD student, will take a lot of courses that are not WASP courses. And that is something which one has to be aware of. And the remaining credits then constitutes the actual research and writing the PhD thesis. What about the industrial PhD students then? Well, they are employed by the company, but they do their PhD studies at a university department that belongs to one of the WASP universities. And it takes 4 years, 100%, but the normal case is that you do it 80%. The company receives 600,000 Swedish kronor per year from WASP if it is 100% level, and 480K per year during 5 years if it's 80%. And this includes a travel budget for the student. And the PhD student must be able to travel under normal situations, not during Corona maybe, but under normal situations. You cannot prevent the student from traveling. And then the academic advisor gets some funding from WASP for the supervision. The PhD student has both an university PhD advisor and an industrial PhD advisor. This industrial PhD advisor is ideally a person with some research experience. Doesn't have to be a PhD, but it could be a person that had been involved in PhDs, helping during supervision and so on. Then the student must spend at least 20% of the time physically at the university and at least 20% physically at the company. But in practice, spending only 20% at the university is not enough. It should, my recommendation is at least 50%. Then there is a contract signed between the company and the university, handling things like IPR and yeah, all the standard issues. But there is no contract between the company and WASP. Then there should be an individual development plan for the PhD student at the company that treats a number of administrative issues. And then there is also an individual study plan for the PhD student at the university. So these are, so to say, the formal documents. Currently, we have around 100 industrial PhDs from 40 different companies. Some companies have a very large involvement. I believe that the largest company is Ericsson, who have at least 10 industrial PhD students. And then we have Saab, Zenseact, former Zenuity, ABB, and AstraZeneca. But most industries, they have only one PhD student each. Research institutes, for instance, RISE and other public organizations, they may not participate in the sense that they may not receive any funding from us. And it's not only the traditional systems industry. I mean, the one you see here, most of them are fairly traditional, but it can also be companies in finance, media, consulting, health, medicine, so on, life science. This call, up to 10 positions. The call opened this Monday and closes 7th of April. The decision by the board will be taken the 20th of May. The earliest start date, 1st of August, and the latest start date, 1st of January, 2022. Normally we receive yeah, I would guess maybe 50, 60 proposals for a call like this, where we typically have around 10, sometimes slightly more than 10 positions to offer. So it's a fairly tough decision to make which projects to fund. You submit the applications through the WASP application portal, and this application should be signed by both the academic and the industry supervisor. Okay, what is then WASP research? What do we do in research in WASP? Well, this is one view of it. We have a matrix with strategic areas, being AI, autonomous systems and software, and then 6 thematic areas: perception and sensing, control and decision making, machine learning, knowledge representation, interaction and collaboration, software technologies and methods, and mathematical foundations and theory. Internally, WASP is divided into 2 or rather 3 large areas. Originally, when WASP was started in 2015, it only said autonomous systems and software. But also then AI and machine learning was a major part of it, but mainly as tools or methods for developing some type of autonomous systems or software system. But then in 2017, the foundation decided that AI should have a more focus in WASP. So that was added, and the AI was, so to say, split in 2 parts. One focused on machine learning, so-called WASP AI MLX, led by Danica Kragic, and one focused on the mathematical foundations, led by Johan Hörstad. And in the beginning of WASP, we had separate calls for autonomous systems and software and for AI. But from this year, it's all joined. So right now we have a joint call for industrial PhD students. They could be in software, or they could be in mathematical foundations, or everything between. So what do the students typically do? Well, in autonomous systems, there is a lot of research on different aspects of autonomy, including all the enabling technologies for autonomous systems. In the next bullet, you see some examples: transport systems, different forms of self-driving vehicles, perception, interaction, visualization, human-machine collaboration, multi-agent systems, robotics, autonomy in clouds and networks, security, localization, and optimization. In common, one can say that these projects often have a very strong systems focus. Then we have the software projects. And software is, of course, a huge, huge area. And all types of software research is not considered part of WASP. It's primarily software research that is either some software methodology or technology that is, so to say, special for autonomous or AI-based systems. It could be for modeling, analysis, development, etc. But something that is, so to say, special for these types of systems that WASP is focusing on. Or it could be software methodology or technology that contains or utilizes some autonomous or automatic or learning-based mechanism. So that is the main types of software that is part of WASP. So what is then the students typically do? Well, here you see a word cloud formed by the title of the PhD student projects in the autonomous systems and software part of WASP. So you can see that autonomous is a big, big word, and the system and network, learning, control, cloud, distributed, and so on. And then we have the similar thing for what the AI students typically do. And then we have learning as the big word, and model, and deep, and networks, as one could expect. Okay, now Danica will go over and talk a little bit about the AI part. So please have a go.
Thank you so much, Karl-Erik. Yeah, welcome everybody attending. So I will say a couple of words about the ongoing project in the AI part of WASP. AI as a field, as you all know, can be studied in a very broad sense. And these are just some examples of areas that are included in WASP. where the methods from machine learning and AI in general are studied both from a very basic theoretical perspective, but then, as also has been mentioned by Karl-Erik, applied in a larger context of both software and autonomous systems. As it has also been said by Anders in the beginning, there are projects that are more towards let's say interactive systems, so maybe physical systems such as robots interacting with humans, or also that we have some projects in the area of in this part of the WASP that also utilize and data and address problems in, for example, banking sector. So again, very broad, and we all learn extremely much from each others. Next slide, please. So to be a little bit more specific for the AI machine learning part, when it comes to the scientific focus, we have back in 2018, when we started, identified 4 areas in order to structure somehow the scientific questions. These are representation learning and grounding, sequential decision making and reinforcement learning, learning from small data sets, GANs, and incremental/active learning, and then multitask and transfer learning. Now, many of the projects fit in, or many of the ongoing PhD projects fit into these 4 areas. Although, as you know, this is also an area that develops quite fast, and we are currently in the process of thinking, is there something new that we haven't considered yet, but that would be worthy of exploring in terms of the scientific, generating new scientific knowledge, of course. Next slide, please. So these are just now a couple of examples of industrial PhD student projects to give you a little bit of the scope and width of the work being done. So this is in collaboration with Elekta, real-time image-guided radiotherapy. So the goal of the project is to improve the quality of life of cancer survivors by minimizing unintended dose to healthy tissue. And the work that is being supervised by Professor Thomas Schön in Uppsala University is then using AI-driven sequential decision-making in real time. And the idea is to use information from the MR cameras to control the irradiation in real time. So I would say that a project like that, it might sound very applied or let's say focused on a specific application. But the scientific problem of actually doing the sequential decision-making in real time is one of the open problems or open challenges in the wide area of AI. So it's extremely interesting from that perspective. Next slide, please. Another example, something that I have already mentioned, is then how AI and machine learning methods are utilized in the financial sector. And here we have a project that is supervised by Professor Henrik Koholt from KTH, where we, again, it's sequential decision-making, the use of generative models and reinforcement learning in order to understand and model basically what is happening on the stock market, for example, how to kind of like look into rather sparse data, but understand and build models in order to be able to actually predict how the whole market kind of evolves. What are potential problems, what are various types of let's say variables or parameters that may affect the performance of the model, and so on. Next slide. And this is, I think, the final example that I have. This is, again, application that is, in this case now, in the area of medicine or medical area. Collaboration between KTH and AstraZeneca, supervised by Professor Kevin Smith. And this is the use of deep learning methods for drug discovery. So the idea is how can one basically predict drug target activity? how one can, based on simulated, let's say, data, understand what kinds of models are appropriate in order to understand how we could both generate new types of drugs, but also kind of like what is relevant, and also from the kind of like more chemical perspective and so on. So rather interdisciplinary. So these were 3 examples, I think, Karl-Erik. These were all my slides. So back to you. Thank you so much.
Thank you, Danica. Okay, so then you put together your proposals and then they should be evaluated. And we essentially evaluate 3 aspects of the proposals, and they are equally important. The first one is the topic of the project, scientific excellence in the project formulation and in the research questions, uniqueness, visionary and novelty nature, and then relevance to, this is actually an error in the slide. It's just relevance to WASP. So this is not particular to AI and machine learning. This is to the entire field of WASP. So that's the first aspect, the project. The second aspect is the PhD student candidate. So we look upon what we believe to be the potential of the candidate for doing a PhD. And there are not so many aspects we can look upon. And the most important then is the grades from the master education or the engineering program in Sweden. So grades are important here. And then finally, the supervisors. What are the scientific merits of the academic supervisor? Do they have some international research experience? What is the potential to strengthen the basic research in WASP? Pedagogical skills and merits, and the ability and experience to collaborate with academia and industry. So if, for instance, the industry advisor and the academic advisor have some previous track record of collaboration and so on, that is, of course, a strong factor. Then you should be aware of that if now your project proposal becomes approved, then this approval is conditioned by the PhD student candidate, that it is the same PhD student candidate that really starts the PhD as the one that was evaluated. So not very, but it has happened in several cases, is that a proposal gets evaluated. After 3 months, the candidate, the student, decides to, oh no, this was not so fun, I will do something else, even before he or she has started. And then the entire proposal is rejected. So there is no second chance. Then I would say also that these 3 aspects are equally important. But if one look upon what is in most cases the problem, that is actually the PhD student candidate, I would say. That the candidate that is suggested from the company and the academic supervisor has typically 2 poor grades in the previous education program. So, elements of a good proposal should fit into WASP, should have a clear and well-defined scientific problem and or research questions, some novelty aspect, and explain why the applicants are the best parties to address this problem, how the university and company complement each other, the added value to academia, industry, and Sweden, and above all, I would say, a strong candidate. If you have more questions, you can always send mails to this general information service at WASP, but then you can also contact the different university representatives for the 7 different universities here. And you find them on the slides. So now some more general issues and questions. How should you find a good project topic? Well, you should think about that this project topic should be sufficiently long-term so that the results are still of value to the company after 5 years or more. I mean, it takes 5 years for a PhD, and it's often not until the last year where the real results come. Then the topic should have sufficient research depth to allow the student to write papers and publications. How should we handle deviations? I mean, it's very unlikely that a PhD student end up with a thesis that is exactly about the problem formulation that was initially formulated. Things happen. The problem is too difficult, or it's too easy, or someone else has solved it already, or the priorities of the company changes, or something like that. So handle deviations is very important, and everyone has to be aware of this. Good PhD student candidate, I mentioned that already. An ideal candidate should typically have a couple of years of experience of the company, but still have the graduate education fresh in mind. So someone that has worked maybe 2, 3, 4 years, but still remember what he did at the university. Good analytical competence, good at problem solving, and good at oral and written communication. And then, of course, good grades, in particular in the courses of relevance. And one should be aware of that many of the courses in WASP, they are rather mathematical in nature. So that is something that the student and the company should be aware of from the beginning. Then the company should try to define or decide upon what is the objective for going into a project like this. And there are many valid objectives. One could be to initiate a long-term collaboration with some research group in order to improve the company's general innovation capacity. There are those that claim that this is actually the most important part of an industrial PhD student project. But then it could, of course, be to solve some challenging problem, to increase the general knowledge within an area that is of relevance to the company or will be of relevance in 5 years. It could be some kind of competence build-up for a very promising employee, or it could be a way to try to obtain a person with sufficient skills to take a leading research and development role after 5 years. Then the company and the student must be aware of the realities of PhD studies. Around 1.5 years is spent full-time on taking courses. And some of the courses could be of less interest to the company and also to the student, but they must still be taken. And then also an important part of the studies, they consist of different travels. Well, not these days, but normally. To conferences, schools, study trips, different meetings. And this is important for the student in order to learn to discuss, to present results, and learn from others. And then if there should be a travel ban, not caused by Corona, then that travel ban should not hold for the PhD student. How should one guarantee that the student remains to be relevant to the company during these 5 years? Well, one good idea could be to set up a research-related shadow project at the company, where intermediate results from the PhD student could be fed in, evaluated, and tested, and so on. Another good way is to formalize the knowledge transfer using, for instance, regular presentations by the PhD student at the company for his colleagues at the company. And then finally, how can we be sure that the PhD stays with the company afterwards? Well, you cannot, of course. So that is also something to think about. How do you start? You start by identifying the PhD student candidate, I would say, and then the academic supervisor. If you don't have contacts in academia yourself, then you can contact the WASP University representatives. And normally, it is often much easier for a person to do a PhD at the university that is geographically close to where he works, so to say. Of course, nowadays with all things virtual, it maybe is easier, but in general, you can never really replace a discussion in front of a whiteboard with a Zoom conference. No way, not in the long run. And then start the project discussions with the academic supervisor as early as possible, because he or she probably knows best which research problems that fit into WASP and which do not. Okay, and then in 2019, we had a special seminar about industrial PhD students in WASP. And we made a small booklet based on that seminar. And there is a lot of this text in these questions and so on. They are actually coming from this document, and you can find it on the WASP Sweden homepage using this address. Okay, that was all for me. So then we switch to Fredrik Heinz.
Thank you very much. Okay, good afternoon. My name is Fredrik Heinz, and I'm the director of the WASP Graduate School. So you have already gotten a kind of an introduction to the fact that as a PhD student, you will do a lot of activities beside your research. And most of those activities within WASP will be will be organized by the WASP Graduate School. So the WASP Graduate School has the the mission to provide to educate the PhDs with skills in the strategic important disciplines within WASP, together with a broad knowledge of AI autonomous systems software development. So it means that we have two parts. We have the deep focused kind of core research competence within the particular topic of the student, but we also have this perspective of the broader WASP area that we also expect the students to know at the end. So the goal from the student's perspective, so what the students should achieve is they should become knowledgeable researchers, of course, in the areas of AI autonomous systems and software. But they should also have a strong community, building a network within WASP, and really feel that they belong to WASP, that this connects them together. And there are a number of different mechanisms to this. For example, there's clusters which connects students and faculty working on different related topics. The students should also get to know Swedish industry. So this is a basic research program, but it's a basic research program for the benefit of for Sweden and Swedish industry. Here, for example, we organize visits to companies and so on. So that's one way, but also at the conferences and so on that we organize, there's always a strong industry presence and connection. And of course, this industry PhD program is clearly connected to the Swedish industry as well. Then the students should also form a strong international academic industrial network. So not only forming a community among the students within the WASP program, but also to get an international network. And the main or the two main activities we have for this is the international trips that we usually do, and also the opportunity to do a semester abroad to deepen this international network. And we really want the students to strive for excellence, so that this should be really the kind of added value on top of a normal PhD program, so that those that really want to push the boundaries and go the extra mile should have that opportunity. So from the graduate school perspective, what do we do? Well, we organize courses and activities to provide state-of-the-art knowledge in the WASP areas. And we organize these courses and activities to respect the needs of both the fact that we have a heterogeneous group of students that are also spread all over Sweden. And this is actually one of the key challenges for us, is that the fact that the students come from many different backgrounds and many different interests. So this is something we work hard to manage and to support. As has been mentioned several times, the students are enrolled in a local PhD program with the rules and regulations of that particular PhD program. So the WASP Graduate School is really added value on top of this, providing extra opportunities not available to all students. So this is really something extra. And as I said previously also, that we provide opportunities for those that really want to excel. So when it comes to activities, we organize a number of different activities for the students. So usually in the beginning of the year, we have a winter conference. So this is a yearly conference for all WASP PhD students. And it's really an opportunity for the students to present their research in a friendly environment and get constructive feedback and criticism on the work that they do. And of course, to build this community and network. Then there are courses. So in the new program that we start, so that these students that get accepted to this industrial PhD student program will follow, has 5 mandatory courses with quite a lot of opportunities to select. I will go into more detail soon, but overall it's 27 credits, so it's slightly less than 1 semester worth of courses. So as the colleague said, many students have 90 credits, so it means that it's roughly 1/3 of the credits will, at least 1/3 of the credits will be WASP courses. The students are of course welcome to take more courses if they want. So this roughly corresponds to 1 6-credit course per semester. So from our, I mean, we expect the students usually to take the courses during the first 2 years. So during the first 2 years, most of the courses that the student will take during its studies, they will take. They may take them later, but that's what we recommend. Then we also organize summer schools. So every summer, usually in August, the middle of August, there is a 1-week summer school. So usually the first summer school is more of a kind of community building, team building. So for students to get to know each other, because they will work along, do research along for the next 4 or 5 years, and of course probably meet for many years after that as well. So that's an important part. Then after the first year, there's usually some specific topics. So we've had summer schools on machine learning, for example. 2 years back, the plan was to have a summer school on autonomous driving last year. Unfortunately, we had to postpone that. So there will always be some interesting topic. Then there is an international trip. So usually 1 week. So far, it's mainly been in October or around there, to go with all your fellow students in your class to some exciting place. So for example, the first year we were in Zurich for 2 days, and then we were in Munich for another 3 days. They have been to Barcelona and Toulouse 1 year. We've been to the US, the West Coast. So then we split up. So half the group went to San Francisco, Berkeley, a bunch of companies. The other half went to Los Angeles, where we visited iRobot, Caltech, USC, and a few others. And then the last day, everyone joined at Stanford, and we had a full day workshop at Stanford, and we interacted with the PhD students at Stanford. So that's of course something we look forward to resume. Unfortunately, we couldn't arrange any trip last year, but hopefully we can resume that, if not this fall, as soon as possible after that. And last but not least, every student have the opportunity to do a semester abroad. So as Anders mentioned in an introduction, we have agreement with a number of different universities, including Stanford and Berkeley, which includes to send PhD students there for a semester abroad. So usually between 3 and 6 months, and that has been very. I mean, many students have really appreciated this, and I think that's a great opportunity to further both in your research interest, but to build this international networks. So my final slide here is about the courses, because usually that is the part which we get the most questions. So there's one course that's mandatory for all, and it's the ethical, legal, societal, and economical aspects of AI and autonomous systems. So this course is given by Virginia Dignam, who is one of the WASP chairs and who is also leading the WASP HS program. Then, so this is slightly new for this new updated WASP PhD program, is that we now have 3 foundational courses in all the three core technology areas: autonomous systems, AI machine learning, and software engineering and cloud computing, so the software part. So here each student has to take at least 2 of these courses. So there is some broadening there. And finally, there is a large set of elective courses. So these include all the courses that existed so far. And we're also developing a few new courses, for example, mathematics for machine learning, for those that want to improve their mathematics. And there's also plans of having a course on interaction, collaboration, simulation, and visualization. So these are in the planning stages. And then there are a number of courses that has been given at least once before. So that means that there's this one mandatory that everyone takes. Then you have to take 2 out of these 3 foundational courses. And then you have to take 2 additional courses out of all the elective and the foundational course that you didn't take. So that's and usually these courses are divided into 3 modules. So where each module has had a 2-day, well, previously it was a physical session. So traveling to one of the universities within WASP, usually where the main teachers of that module are located. So then there will be lectures, seminars, social events related to that. And then in between these course sessions, there would be either individual work or work that you mainly do at your university with other students in your class. So of course, now the last year, the courses are currently given on remotely, but the plan is to, when possible, resume these physical sessions. And the main reason for that is really that this social and community building aspect is a very important part. It's not only the course content and getting more knowledgeable, but it's also building these networks, and that's much harder to do in online fashion. So one more thing regarding courses that since previously, basically the courses were all mandatory, that kind of kept the class of students together. Now that we expect more, I mean, the students will choose different courses. The plan is to have a joint course session every semester where multiple courses will be given at the same time, so that students will get even more opportunity to meet and interact both between the classes and get a broader network. So the courses are really important. And I should also say that these courses have been developed exclusively for WASP, and they are not available to students outside of WASP. So this is really a unique opportunity to get access to this. So with that, I'm done. And I'm sure there are questions that I'm looking forward to answering.
Okay, thank you very much, Fredrik. I think there's been a stream of questions coming in here.
Maybe you want me to take some directly, or?
I think we can maybe address, before we let Claes Lundström talk, we can take some of them. There's been a lot of questions about international aspects, whether you can be abroad or if you can come to Sweden, and all of those aspects. And I guess the answer to most of those questions is that the fundamental requirement is that you are enrolled in the PhD program at one of the WASP hosting universities, fulfilling the requirements of that PhD training. That's sort of the basis of the whole thing. Karl-Erik and Fredrik, do you want to add more information to that response?
I mean, one aspect is, of course, that the courses will be given in Sweden. I mean, as I said, we will have these physical sessions when we can, and really meeting and interacting with other students is really important.
Mm-hmm. And then there was the question about industrial PhDs, if they are eligible for the semester abroad, and of course that is the case. You are following the full program. So if there are any no open questions at this point, but it looks as if many of them are also related to the reviewing process and what is taken into account. And of course the PhD candidate is something that we look at as well. And in contrast to other calls, the actual individual who's becoming the PhD student is also an important part of the review. But of course, in that process, we take into account whether you are currently a student, if you're not employed by the company, your seniority, if you have previous experiences or work life, and if you have publications in the past, all of that is taken into account. But when doing that, of course, we are looking at your stage and what kind of experiences you have, what can be expected out of that. So many of those things are there that we are evaluating, but that's nothing that is a showstopper if you don't have any of those things.
So there's the question now, as a PhD applicant, what is the first thing to do? And I think here is what's very important is that it's the company together with the university that does the application. So if you are a, say, a master's student wishing to do a PhD, an industrial PhD, you need to get in touch with companies that could then apply. So you cannot apply as an individual student. This can only be applied by the companies.
That is correct. Okay, there will be a Q&A session towards the end here as well. So should we let Claes Lundström tell us about his experiences and with Karin Stacke? Yeah.
Yes, great. I hope you can see my screen. So I'm here to tell you a bit about the industrial perspective of actually running these projects, industrial PhD student projects, and most importantly, Karin will follow me with her personal experience now being in the middle of one. But I'll start with a bit of background and context to what Sectra is doing. We have, well, in a nutshell, these are the three branches that what Sectra does. Imaging IT Solutions is the main one. It's about diagnostics and medical imaging, providing IT solutions for that. So as you can imagine, lots of opportunities for AI to come in and help healthcare do better, so to speak. We have secure communication that's about encryption, such as the encrypted cell phone you see there, and critical infrastructure, cybersecurity solutions, etc. And then we have a kind of greenhouse inside Sectra that we call business innovation, with a couple of smaller business lines, and that's also where the research department sits, which I'm heading. Just to get an idea of the size of Sectra, we have we're a very international company, even though headquartered here in Linköping, and customers in more than 60 countries, more than 800 employees, and approaching 2 billion crowns in sales. And to characterize Sectra in this context, it might be good to know that we have a fairly high academic level. Majority of the colleagues here have a Master in Science or equivalent. There are a few percent PhDs as well, but perhaps more importantly is that the CEO has a PhD and that type of background, which kind of sets a bit of culture in the company in terms of how we look upon these types of collaborations. So the research department that I'm running, we're 7 people, and most have PhDs or are on the way of attaining one. And in short, the research department, we have the task in the company to be kind of a service unit in terms of long-term developments for the company. So we want to be the antenna into monitoring the state of the art in science. What are technologies that can be useful down the road for Sectra? And also to actually develop new knowledge. We often find that while there's very exciting fundamental research and very nice starting points for us, there's also a great need to actually bring that into the domain that we work, and science advances are needed to make it work in our domains. And we do a lot of prototyping as well. And the main way we do work from the research department is in a collaborative setting, together with academia and together with healthcare in triple helix collaborations. So then a question is, why do we have a research department at Sectra? Why do we think that having in-house expertise is important? I would say that it really boils down to a couple of aspects. Is that, of course, we could just use the collaborative mode and tap into expertise elsewhere. But we find that to really create high quality and future-proof innovation, we need these individuals that can actually speak several languages, in a sense, that they need to master the academic theory. They also need all of that experience of clinical reality that is really the backbone of the sector expertise, because those are the people that we need to provide services for. And we also see that the connection to our colleagues in product development is really important, because that also sets a very important frame of what's possible and what's necessary and what are the needs, etc. So that's actually a very important part of how we see things and how we work at sector research, that in order to make that translational step within the company from the prototypes, for instance, that we do, we need to think about how to do it in a way that it's easy to pick up on from the product development side. So it's very good for us that we in the research department have people with experience also from development, knowing about, for instance, deployment issues. If this is going to work for 1,000 customers, 24/7 hospitals around the world, well, there are some requirements that come with it. The background for us is that this is a regular thing we do, industrial PhD students. So myself, I was one back in the day, and we're currently running 2 projects within WASP. So we have established quite a lot of experience of how to do this well, I think. And with that, I'd like to leave the floor to Karin to explain her perspectives being in the middle of such project. Please, Karin.
Great, thank you. Hi, everybody. My name is Karin, as Claes said. Claes, could you please give me the next slide? Well, yes, so you all know I'm an industrial PhD student at Sectra and Linköping University. I started in fall of 2018 as a part of batch 1 in the WASP AI graduate school. Before that, I was working at Sectra as a software developer. I was at Sectra about 1.5 years before starting my PhD. So I suppose it was kind of like spot on there, working a couple of years at the company before. So this is just a picture of me presenting a poster at a conference in China, pre-pandemic. Yeah, could you give me the next slide, please, Claes? Being an industrial PhD student is really being part of 2 different worlds, the industry and the academic one. And I just wanted to give you some of my experiences and perhaps highlight some of the characteristics that are different between these 2 in my situation, and just highlight some of the ways that they are actually complementing each other. Because I kind of also want to say that, as you all know, these are my very subjective opinions. I think that the setup or the circumstances for an industrial PhD student is very different, depending on your company, depending on the university, the group that you're in, and of course also the student itself. But let me start giving you some how things are for me, at least. So the majority of my time is spent at Sectra, at the office there, of course, when it's not a pandemic. Now I'm only at home. So I am actually doing 100% research. So the plan is to finish in 4 years. So I have my main office at Sectra, and I really enjoy having actually being physically at the building there, because it really reminds me of the real world outside of research, in the sense that you meet people that work with actual customers. You are reminded of why these research questions are important, and so on. And of course, there is also a lot of in-house domain knowledge about yeah, the research questions I'm working on. As Claes mentioned, we have a research group at Sectra, so I'm part of that, which is really, really good, I think. I have very helpful colleagues, and that is really an important part for me, at least, to feel that you're not alone as a PhD student, even when you're at the company. On the academic side, I'm part of a group at Linköping University, which is situated in Norrköping. So I try to go to Norrköping once a week to meet them there. And of course, the focus is different when you're at the university. Everybody is doing research, and it's really nice also to be part of that community, because what I do most of the days is research. So when you're at the company, it could sometimes feel that yeah, a bit isolated, in the sense that no one is working on the same questions as you are. But when you're at the university, people have the same mindset, which is nice to have that perspective as well. In addition, there's a lot of PhD students there. In our group at Sectra, we are 2 PhD students, which is nice, but at the university, we are a lot more. And it's always nice to just be able to discuss with other people that are in the same situation as you are. You can get to discuss just research questions, you collaborate, and also just vent all the angst of being a PhD student, as you may know. And these are really just, these 2 worlds really bring 2 different perspectives on my research topic. And I think that these perspectives are materialized, in a sense, in my supervisors. Can I get the next slide, please, Claes? Thanks. Yeah, so I have 3 supervisors. Industrial supervisor is Claes, of course, and then I have a main and a co-supervisor at the university. It's Jonas Unger and Gabriel Eilertsen. And as I said, different perspectives can be nice. It can also be challenging. So I think that a good collaboration between the supervisors is really essential, because you definitely want your supervisors to be pulling in the same direction. Otherwise, it's the PhD student who is caught in the middle, trying to balance all the different conflicting ideas and priorities, perhaps. So I think in my case, this has not been a problem. We have had good collaboration. I think that my supervisors understand each other and they trust each other. So that is really important. Okay, Claes, could you take the next slide, please? I just have some final thoughts I wanted to say, and some advice, perhaps. In my case, perhaps it's me personally, but I think that what has been the most important part of my studies so far, these 2.5 years I've been doing, is really about the social context and the support I feel. So it's both from my supervisors, but also from my colleagues. And I think it's really important to be aware of that when you are an industry that might not have had a PhD student before, and you don't have a research group, perhaps. That you can feel quite isolated and distant from the rest of the company when you are doing research instead. So just be mindful of that. So it's really, for me, it's been really important to have the research group at Sectra, and also, of course, the group at the university, to really just be able to have people that understand your situation. I also think that it's very important to be clear with the expectation, especially in terms of work versus research. So it's very common that the industrial PhD student work for 20% for the company. And I think it's very important that the expectations are clear and that they are reasonable, because I think that in many cases, at least, WASP students are very ambitious, and it's easy to feel that you're not doing enough, both on the research side and perhaps on the work side. So just having a good work-research balance, I think it's important, and also that this is this is something that your supervisors, both on the academic and the industry side, understands. And finally, being a WASP student has been a great experience, I think. I think all the things that Fredrik mentioned about the courses, about the networking, about meeting other PhD students has been great. I've really enjoyed the summer schools, and this fall I'm going on an international visit or a semester for 6 months at Stanford University, which is really a nice bonus, I'd say, to my PhD experiences.
Great, thanks, Karin. We'll be around for questions as well. I just had a few final slides on some additional thoughts on success factors, tying a bit back to what you said, Karin, and what Karl-Erik said in the beginning as well. I think it is very important on the characteristics of a PhD student in order to make this work. It is a difficult task to be an industrial PhD student, and especially WASP is about excellence, and it's challenging. So you want someone who has self-management skills. It's juggling two worlds will by necessity mean that you will need to manage that on a personal level, even though there are a bit of differences in between. I would say higher ability than average PhD students is necessary. And as we've said, a few years at the company makes a lot of difference. So I think that is optimal if you can have that experience with you in going into the project. And there is some, I think you reflect that a bit, Karin, as well. There is a bit of uncertainty, and maybe that's always the case in PhD student projects, but even more so if you have that industrial experience, because things are a bit more structured in projects, etc., deliverables and schedules and whatnot. And it can be a bit stressful to go into academia with the unclarity and freedom and not in the first year knowing exactly how am I going to get to that PhD, etc. So that, I think, is a personal skill that it's good to have as well. And several of you have been talking about the industry academia understanding, and I just want to stress that again, that there must be mutual insight and respect from both sides. So, for instance, academia must understand the prerequisites for a company, that even though research is long-term, it must be connected to a profit-generating thing, even though it might be some years away. So that is what companies need to be about. And of course, even with WASP funding or other funding, allocating a PhD student, investing in somebody's education in this way, that is a huge investment. If you really think about that, I think that gives a nice platform of respect to start understanding the company perspective. But then again, what some companies not used to academia on these collaborations might struggle with is that they need to understand that this is not some kind of consultancy thing that you can buy some results with this investment. Research is still the same. It must be independent. It must take high risk. It must be publishable and have all the academic requirements fulfilled. And there's also a lot of auxiliary activities, and I guess they're for good reasons that Karl-Erik is talking about. Travel bans should not be an issue. Even though a company has one, it shouldn't be issued here, of course. So that type of understanding. And in general, a culture on both sides promoting this type of cross-sector collaboration and this type of translational activities, I think, is important. Finally, I think that IP might be an issue in some cases, and I just want to promote that you should really have from both sides a balanced view on IP. I think this often is much more of a problem than it needs to be. So from a company perspective, I sometimes hear about sharing phobia. In the way we see it, it's almost always an advantage of publishing the new things that come up in the research collaboration. You need to sharpen the advances by putting it out there and getting the feedback and making it even better. And you need that type of publicity as well. If you have the world's best thing and nobody knows about it, and you don't have any external evidence that somebody else thought it was good, then it's not going to be that useful. So of course it might be different in different industries for different companies, but in my view, companies tend to be a bit more secretive than they need to be, and than what's good for them actually. And it's also important for academia, if you don't have any experience on the industrial side, you might think that all of that value is in the actual good idea, or you get it patented and then you're done. Whereas from an industrial perspective, that is just even with the best idea, there's just a starting point of something that will cost you a lot of effort and cost to pursue the patent, to develop the thing, to market it and sell it, and even then you're not sure that you will make a profit out of it. So sometimes I think academia can overrate the value of the idea in itself. To me, the value is mostly in the having built that really good constructive collaboration with long-term relation with an academic partner, that you can really grow these things over time. So the main risk is not that the IP outcome will be unfair, but that the project never gets started because you're afraid of unfair IP outcome. And with that, I will close my slides, and we're happy to take any questions now or later. Thank you.
I was asked to give a short clarification of one thing, so maybe I can show my slides again. Okay, I got a comment on that the evaluation criteria that I showed in my slide was not exactly the same as the ones that are on the web. And there are 3 points where they differ. The first one was that I said that the relevance to WASP for the project was important, and in the web page it is not included, but of course it is included. A project that is not within the scope of WASP will not be considered at all. Second issue was that I said that potential to strengthen basic research in WASP was a criteria, but it's actually not. I mean, in particular for industrial PhD student projects, they can actually be of a fairly applied nature. But then there is this important criteria that I forgot about, underrepresented gender. So if we have a constellation where the PhD student candidate and or the supervisors are of the underrepresented gender, that is taken into account in the evaluation.